Hey, Unites, welcome to Thursday's Double. We're taking a look at exercise 7F today, which is on similar figures. Now, similar figures isn't quite like congruent figures or congruent triangles. We're still dealing with the same shapes, but instead of congruent being the same now, the shape has been shrunken or enlarged, but obviously the angles and the shape is still the same. What do they look like? For example, if we have like an irregular trapezium, um, we can see the shape on the left here has considerably been shrunken compared to the shape on the right, or it's just smaller than the shape on the right. And if you look at the side length AB, compare it with EF, we can see this shape on the right is 2 times bigger than the shape on the left. So the biggest takeaway I want you guys to know is when we deal with similar figures, we have a thing called scale factor, which just tells us how much bigger the larger shape is compared to the smaller shape. And you would take a corresponding side and you would divide it with the smaller shape's corresponding side, with the larger number always being on top and the smaller number always being on bottom. Okay, and then we can see the scale factor, which tells us shape on the right is 2 times bigger than the shape on the left. If the scale factor was 1.5, then that means the shape on the right would be 1.5 times larger than the shape on the left. If it was 3, it would be 3 times larger, so on and so forth. Let's do an example to put a context to this. So here we've got ourselves a pentagon. It's been slightly rotated, so the one on the left here is smaller than the one on the right. What I want you guys to always make sure you do is just highlight the corresponding sides. So what that means is in the original on the left, the 4 centimeter here corresponds with the 6 centimeters in the right image. The Y centimeters, or actually let's do the slant first, the 3 centimeters is corresponding to the X, and then the Y is corresponding to the 7.5. Now that you've known which sides are corresponding to what, firstly we need to figure out the scale factor. We can't figure out the scale factor with the green and blue sides because there's a pro numeral in the corresponding shape. So we can use the yellow sides to find the scale factor, which we go SF for scale factor equals the larger number on the smaller number. Always a larger on the smaller. 6 on 4. Put that into your calculator, you get 1.5 or 1.5. So basically this pentagon on the right is 1.5 times bigger than the one on the left. If we were to find X, what we do is we use our scale factor and we find the corresponding X sides. So X is corresponding to the 3. We know this shape is 1.5 times bigger, so that means this side length here, where the X is 1.5 times bigger than 3, which would mean mathematically we would go 3 times the scale factor of 1.5, which would tell us our answer is going to be 4.5 centimeters. C, we got to find the value of Y, so let's keep it on the same screen so you guys have a reference point. So if we're looking at C here, the value of Y, well, that's the blue corresponding side length. We know the image on the right is 1.5 times bigger, so this side here is 1.5 centimeters, sorry, 1.5 times smaller than the 7.5 centimeter in the right image. So here what we would do, if it's smaller, we would go 7.5 times. Whenever we go from large to small, the whole thing is disappearing. Whenever we go from large to small, we divide. Okay, so this would be divided by 1.5. 1.3, 3.5, 6. So this will get us 5 centimeters. Okay, input that into your calculator if you're unsure. Don't forget the units because we are dealing with side lengths. And yeah, just remember going from big to small, you divide. Going from small to big, you multiply. That's it. But take a look at exercise 7F, and what we have is, in the old textbook, have a go at question 7. And in the new textbook, let's see, what would that be in the new textbook? New textbook would be question 3. All right, please do all of them, and that's it for the double. Thanks, everyone.